Okay. So now when we're hush children, I'm teaching you. So now when we're adding these two together, we have to create a common denominator. So I'm going to have negative 6 over 3 plus 10 over 3. And what does that equal? 4 over 3. Go back to our A, B, and C. What is this if we're making a ratio out of A, B, and C? Matt? This is negative B over A. That's not a coincidence. That's not a coincidence. The sum of the roots, if you add the two roots together, it will always end up being negative B over A. Now let's see what happens when we multiply the roots. So now let's do R1 times R2. So we got negative 2 times 10 thirds. Well, do we agree that's going to be a negative 20 over 3? Right, so now looking back at A, B, and C, if we're making a ratio out of those, what is this representing? Negative 20 over 3 is the same as Arish? I don't know. Now I'm confused all the time. Arish? Arish? C over A. You got it. Okay. Normally at this point, I would prove this to you, but I'm not going to. I just want to use it. So let's just write it out. Let's write out sum of the roots. It's going to be R1 plus R2 is always negative B over A. And then we're going to have the product of the roots. So R1 times R2 will always give us C over A, and that's obviously assuming A cannot equal 0. Okay, so now let's do a problem. I'm going to tell you without solving, find the sum and product of the roots. And our equation will be 2x squared minus 9x minus 6 equals 0. Matt, where's Simon? Oh no. All right, do we all agree that A is 2, B is negative 9, and C is negative 6? A is 2, B is negative 9, C is negative 6. All right, so now they're saying without solving, we want the sum and product of the roots. So let's start off with root 1 plus root 2. Well, we had learned that root 1 plus root 2 is going to be negative B over A. So what does that tell us? The sum of the roots will be negative B. Well, if B is negative 9, what's negative B? 9 over A, which is 2. Easy peasy. All right, now let's do the product of the roots. Well, R1 times R2, we learned that that's going to be represented by C over A. So RC is negative 6, so the product of the roots will be negative 6 over a, which is 2. Oh, sorry, you're right. We should simplify this. Negative 6 over 2 simplifies down to negative 3. Thank you. Okay, do you think it's always going to stay this simple? No, of course not. Okay, so now I want us to write a quadratic equation in standard form that has the given roots. All right, so the first one, we'll call this A. We have root 1 is negative 5/4, and root 2 is 16 over 5. Not 15, 16 over 5. Now, when I say I want a quadratic equation in standard form, that means I want ax squared plus bx plus c. But I didn't say a quadratic expression. I said in a quadratic equation. So what does that mean? I have to equal it to 0. So in order to do this, the quickest way to do this, in my opinion, is to use the sum and product of the roots. So I know root 1 plus root 2 will be negative b over a. So now I'm going to go ahead and I'm going to use this. So I'm negative 5/4 plus 16 over 5. I'm going to create a common denominator, which is 20. So we're going to have negative 25 over 20 plus 24 over 20 is going to give us, you got it, root 1 plus root 2 will equal negative 1 over 20. And shouldn't this represent negative b over a? Okay, so right now I know my a is 20 and my b is positive what? Oh, I did 6 by 4, not 16 by 4. Sorry. Let's fix that. So then this is 64, which changes everything. That makes it 39. Is that better? Positive 39? Positive 39. Okay, so now we have 39 over 20, which is negative b over a. That's okay. Our a is still 20. Our b is now negative 39, because negative b is positive 39, which means b has to be negative 39. Right, now we need to find c. How am I going to find c? I'm going to use the product of the roots. Root 1 times root 2 gives us c over a. What were the two roots? Negative 5/4 times 16 over 5. So now when we multiply these, we're going to get negative 80 over 20. Can we technically simplify 80 over 20? Yeah, but you don't want to do that because you want your sum of roots and your product of roots to have the same a. If you're now creating different a's, that complicates things. So do you see how the sum of roots had an a of 20, and then when we multiplied the product of the roots had our a as 20? You want to keep that the same. So in this specific scenario, you do not want to simplify. Sometimes you'll have to simplify to make the a's the same. Right? Sometimes you'll have to change one fraction to make it the same a as the other fraction. Do you see what I'm saying? So we want in the sum of roots and the product of the roots for the a's to always be the same. So now in this scenario, once again, we have a is 20 and our c will be negative 80. Do we have everything we need to write out this quadratic equation now? Yeah, so the quadratic is ax squared plus bx plus c equals 0. So we're at 20x squared minus 39x minus 80 equals 0. Do you know how else we could have done this? Anybody have another idea? So I'm saying root 1 is negative 5/4. Root 2 is 16 over 5. Jason?
Just expand x minus r1 times x minus r2.
Say it one more time.
Expand x minus r1 times x minus r2.
Close, yes. So we could have done this as x minus 5/4, which is the same as x plus 5/4, but not exactly. And this could have been x minus 16 over 5, but that's not exactly correct. If we're really going back to the factors, this would get us the quadratic, but to go back to get us the proper quadratic, this would get us the roots, but to go back and get us the proper quadratic, we would have to actually take this a step further, but Jason had the right mindset, set it back to factors. David?
Wouldn't it be like 4x plus 5 and 5x minus 16?
Yeah, so remember, if this was x equals negative 5 over 4, we're sort of going to backtrack to the factors. How do we backtrack? The last thing we did was divide, so the first thing we'll do to backtrack is multiply. So this becomes 4x equals negative 5, and then what are we going to do? Add that 5 over. So 4x plus 5 would equal 0, so that was our factor, right? And the same idea here for the root 2, we have x equals 16 over 5. We're going to now backtrack to the factor. So the last thing we did was divide, so the first thing we'll do is multiply. So now we'll have 5x equals 16, and then subtract that 16, which gives us 5x minus 16. And then what can you do with the 4x plus 5 and the 5x minus 16? Foil it out. Thanks. Made it up myself. All right, so let's keep going. Again, same directions. I want us to write a quadratic equation in standard form. So our root 1 is 5 plus 2i. Our root 2 is 5 minus 2i. I'm going to stick with the sum and product. We know root 1 plus root 2 is going to give us negative b over a. So I'm going to go ahead and add these 5 plus 2i plus 5 minus 2i. What happens with the 2i's? They cancel, so we're left with 10. So 10 equals negative b over a. What does that mean for us? B is what number, David? B would be negative 10. You got it. And what about A, David?
Just 1.
1. All right, so that gets us B and A. Now I'm going to use the product of the roots, R1 times R2. So that's 5 plus 2i and 5 minus 2i. And you can FOIL this out, or you can remember that this is a dots, but it's a dots with I. So A plus bi times a minus bi is a squared plus b squared. You got it. So this is going to give us 25 plus 4, which is going to get us 29 over 1, which represents c over a. So now, do we have the same a's in our sum of roots and product of roots? Both a's are 1, so we're in good shape. So the last thing we need to add is our c, which is 29. Can we come up with a quadratic equation? Yes, it's going to be x squared minus 10x plus 29. Do I have to put equals 0? Yeah, because I asked for an equation. If we didn't, we'd get that wrong. All right. Next one. Yeah. So now I want us to find k such that -3 is a root of x squared plus kx minus 24 equals 0. Do we have this written down? Okay, so let's figure out what we do know. We know A is 1, we know B is K, and we know C is -24. And what else do we know? We know root 1 is -3. All right, so we have, I'm going to go ahead here. We know root 1, well, let's go by numbers we do have. We know we have root 1, we know we have C, and we know we have A, right? We don't have root 2, and we don't have B. Do you all agree? All right, so I'm going to go and find root 2 first. Find root 2. How am I going to find root 2? Well, if I have A, C, and root 1, can I use the product of the roots? Because root 1 times root 2 equals C over A. So I'd really only have one unknown here, so I can solve for it. My root 1 is 3. My root 2, we'll just, I'm sorry, oh, -3, thanks. My root 2, I'll just call root 2, R2. My C is -24, and my A is 1. So what is this? -3 times R2 equals -24. Divide by -3. So what is our second root? 8. All right, so now I know more. So now I know A, I know C, I know root 1, and now I know root 2 is -8. So I need to just basically find the B. So what am I going to do now? I'm going to use the sum of roots. Root 1 plus root 2 is equal to -b over A. So I'm going to have -3 plus -8 is going to equal -k over 1. Did everybody see what I did here? Our B is K, right? So I just plugged it in. Root 1 plus root 2 is -b over A. Well, B is K. So -3 plus -8 equals -b, so that's -k over 1. Travis?
Isn't -24 divided by -3 positive things?
Oh. Yeah, where did I get negative from? Y'all are stopping me too late. Okay, so now we're going to have 5 is equal to -k. So what does k equal? -5. So we found k. Yes, Chris?
Can you just plug in -3 into a quadratic and then just solve from there?
Yeah, but it's not always going to be that simple. So I'll show you ones where it's a little bit harder. So I wanted to do it the longer way. Okay, next one. Okay, let's try this. Okay, let's try this one. I'm just trying to jump around here. Okay, actually, you guys try this one on your own. Find k such that 1 plus I is a root of x squared plus kx plus 2I equals 0. Oh, sorry, find the other root and k. Sorry, find the other root and k such that 1 plus I is a root of x squared plus kx plus 2I equals 0. There we go. So what did we get? What did we get for root 2?
1 plus I.
Yeah, it is 1 plus I, but wasn't that the same as root 1? What does that mean? That is mean its k is negative 2 minus 2I, but what does that mean when root 1 and root 2 are the same? What does that mean when root 1 and root 2 are the same? Yeah, it's like a double root. Basically, what's happening, generally when you have a parabola, it goes through, right? It hits a point, it goes through, and then comes back up. When it's a double root, when your root 1 and your root 2 are the same, what that means is it's hitting the point and coming back up. So that point counts twice. Because it's x squared, you need 2 answers, right? So that's what that means. So that's completely okay for root 1 and root 2 to be the same. Okay. And then Matt did tell us that k is going to be negative 2 minus 2I or negative 2I minus 2. It doesn't matter. Anybody need to see me do this? Yeah. Can I do k? Sure. Did you say wait? You're okay? Okay. One more and then we'll call it a day.
Bro, that feels very satisfying. That actually is pretty satisfying.
Okay.
Okay, that's an and sentence. It doesn't say three. Okay, so we don't mess up. It says find the square root and value of 2. Got it. You get 3. 3.
Are we done? All right, what'd we get? I got the same. Who needs to see me do this? We'll do it? Okay. So, Dravid, let's go through what we know. What's A? 1. What's B? What's C? K. Okay, and what's root 1? Negative 1/2. All right, so let's start off by finding root 2, and then that will help us get C. So how are we going to find root 2? Well, I'm going to look at what I have. I have a value for A, I have a value for B, and I have a root 1. So which one uses A and B, the sum of roots or the product of roots? The sum of roots. So we're going root 1 plus root 2 equals negative B over A. So now this is going to be root 1 is negative 1/2 plus root 2 equals negative 5/2 over 1. Does it really matter that it's over 1? No. So this is saying negative 1/2 plus root 2 equals negative 5 over 2. I'm now going to solve for root 2, so I'm going to add that 1/2 over. And when I add the 1/2 over, I'm going to get root 2 is equal to negative 5 plus 1 is a negative 4 over 2. So we don't know really, are we going to leave it or are we going to divide it? In this scenario, I would simplify it because we already know what A is and we're just trying to find C. Does that make sense? So that's why we know in this scenario we can divide it and get root 2 is negative 2. Are we okay?
Yeah.
There. So now we have root 1 is negative a half. Root 2, what did I say, is negative 2? Okay. So now we just need to find c. So now we're going to use the product of the roots. Root 1 times root 2 equals c over a. Well, our root 1 is negative a half. Our root 2 is negative 2. And that's going to equal k over a. But what's our a? 1. So it's just k. So we have negative a half times negative 2 equals k. When you multiply fractions, you're allowed to cross cancel. So negative 2 goes into negative 2 negative 1 times. Negative 1 times a negative 1 is a positive 1. You good?
Yeah.
All right. I'll be nice today, and I will say no homework. Don't get used to it.